in this Bode plot, we have to find the value of omega 2. Okay. Now what is the value of omega 2? Based on the slopes, we can find the values of omega 1, omega 2 and omega 3. Okay. Now to find omega 1 here, now what is the point here? We have to see from omega 1 to this point. At omega 1 we have magnitude of 36 dB. Okay, this is 36 dB. At omega equal to 4 we have magnitude as 0. Now what is slope here? 36 minus 0, that is y2 minus y1 by this x-axis in terms of log. So log 4 minus log omega 1, which is equal to minus 40 dB per decade. Okay, now from this you can get omega 1 as, if you substitute these values, okay, we will get omega 1 as 0.5 radians per second. Now similarly, to find omega 2, okay, this is the slope, we can consider it. Okay, what is that? At this is minus 12 minus 0 by log omega 2 minus log 4 is equal to minus 40 dB per decade. Okay, from this you will get omega 2 as 8 radians per second. Similarly, we can calculate omega 3. Okay, that is slope of this one. The slope of this plot is given as minus 20 dB per decade. Okay, now what is the value of omega 3? Now what value of omega 3 is minus 12 minus of minus 21 divided by log omega 2 is 8 log omega 3 is equal to slope is minus 20 dB per decade. From this you will get omega 3 value as 22.5 radians per second. Now these are the values of omega 1, omega 2 and omega 3. Okay, now look at the first question here. This is also a linked question. Okay, question number, okay, no need of question number. Okay, the value of omega 2 is 8 radians per second, option A. Okay, now if you see here, transfer function, this is a linked question. Now next we have to find transfer function. Now what is the transfer function here? K times of, we don't know the magnitude of K right now, okay, because we don't know the initial magnitude present at that point. Okay, up to this point we know it as 36 dB. Okay, now this is K times of, now what is the transfer function we have at omega 1 equal to 0.5? That means initial slope is minus 20 dB per decade. That means you have a pole at origin. If you have a pole at 0, it will be plus 20 dB per decade. That is the initial slope of the plot. Okay, now if you see here, initial slope is minus 20 dB per decade. There is a pole at origin, and at omega 1 the slope is minus 40 dB per decade. What does it mean by that? There is addition of pole. Okay, at omega 1 is equal to 0.5. So this is 1 plus s by 0.5. Okay, up to till omega 2. Now at corner frequency omega 2, that is 8 radians per second, the slope changes to minus 20 dB per decade. What does it mean? But there is addition of 0 at corner frequency omega 2. Okay, that means you have 1 plus s by 8. Okay, this is 1 plus s by 8. This is a transfer function we are seeing here. K times of 1 plus s by 8 in the numerator. Okay, now similarly you have one more pole at omega equal to 3, omega 3 equal to 22.5. so this is 1 plus s by 22.5 radians per second. Okay, now this is what the transfer function of the Bode plot. Okay, now we have to find the value of K. You can find it any value, okay, whatever you want. Substitute omega equal to 4. At omega equal to 4, what is the magnitude of the plot which is 0 dB per decade. Okay, here this is 0 dB per decade. So you can substitute any value. Okay, I am considering at omega equal to 0.5. Okay, now 20 log k 1 plus 0 j times of 0.8 by 0.5 by 8 plus s is equal to j omega. So this is j times of 0.5 into 1 plus j times of 0.5 by 0.5, okay, into 1 plus j times of 0.5 by 22.5, which is equal to at omega equal to 0.5 radians per second, we have slope of 36 dB. Okay, we have a magnitude of, not slope, a magnitude of 36 dB. Okay, you can neglect these terms. This is numerator term, you can neglect this one because 0.5 by 8 is very almost, we can take it as square root of 1 square plus 0.5 by 8 whole square is equal to almost it's 1. Okay, similarly you can neglect this one. Okay, now from this you can find k value as 31.62 approximately. Okay, 31.62. Now what is the option? Option A is correct. Okay, see here in option A he has written 1 plus s by 0.5 as 2 times of s. Don't put this as 1 plus s by 2. Okay, this is not correct. This is s by 0.5 in this second B option. So option A is correct.
Is consider the system depicted in figure 1 shown below and the Fourier transform of the input signal is shown in figure 2. Let z of t equals z of t and z of j omega Fourier transform pace, and y of t and y of omega are the Fourier transform pace. Sketch the z of omega if omega t is this. See, z of t is equals to x of t into omega or w of t, that is x of t into cos 5 pi t, which is nothing but 1 x of omega minus 5 pi plus x of omega 5 pi. So if we apply this transformation to the figure 2, we will get an answer as option A. Is consider the system depicted in figure 1 shown below. The Fourier transform of the input signal is depicted in figure 2. Let z of t, z of j omega the Fourier transform pace, and y of t and y of j omega the Fourier transform pace. See here, h of omega is in frequency domain is represented as 6 pi minus 6 pi, magnitude is 1. Okay, means we are posing the z of j omega, that is 1 by 2 x of omega minus 5 pi plus x of omega plus 5 pi through this one. So complete z of j omega is passed through the h of j omega. So after passing this one, we are multiplying with, that is again y of t is nothing but z of t into w of t, then it results in y of omega as 1 by 2 1 by 4 x of omega minus 10 pi plus 2 x of j omega plus x of omega plus 10 pi, which is equals to the figure D, hence option D is correct.